Okay, at this moment, let's encrypt and decrypt the message in Mississippi by Hill Cipher with the key matrix 3, 25, 24, 17. Okay, first, encryption. Because the dimension of this matrix 2 by 2, we know we have to make a partition of this given message into size of 2 pieces, right? So we need to change mi first, and at this moment the alphabetic position of mi is 12 and 8, which is not the real alphabetic position. It's rather the ciphering position, right? So a assigned to 0 and I assigned to 8 instead of 9, something like that, right? So in the previous example, we used just original alphabetic position of each letter, but in this case, it's more likely, it's better to change starting from 0 to converting this letter to numbers, right? So we just follow it, and technically it doesn't mean anything, because if you just using original alphabetic position, then we need to simply changing 26 for G into 0, right? So if you just agree between senders and receivers how you want to convert this number, the letters to numbers, actually you can actually giving another cipher to enciphering these numbers. So if you make it, which makes more secure the message, right? Okay, so if you have 12 and 8 for M and I, all we need is just multiplying these two numbers with this matrix. And after calculate it, actually 3 times 12 plus 25 times 8 is going to be a big number, but the remainder after divide by 26 is going to be 2 for that. And for second part, it's going to be changed to 8. So the corresponding letters for these two numbers is going to be C and I. So the ciphertext for MI is changed to CI. And we do the same thing for the remaining message. And it really happens a lot, like we need a blocking or partition of the given message with a certain length. So what happens if our original message has odd numbers of characters instead of even? Then there must be one character left, right? Then how can you make this kind of calculation if we don't have any number at the end, right? So in that case, you can just put any character, and most likely how about X for that. So at the end, you just put X's as many as you need. If it's a size of 2, then all you need just put X whenever it's necessary. But if it's size of 10, then the worst scenario is you might need 9 X's at the end, right? So if you have many X's after deciphering your ciphertext, you can just ignore that, right? Okay, so Mississippi changed to these characters. And how about this description of that? Let's pretend you're Alice and you receive this ciphertext from Bob, and you want to get the plain text out of it. You already know the matrix A, but we just need the inverse of it to deciphering the message. Okay, if it's a 2 by 2 matrix, then we have some kind of formula or procedures to get the inverse of it. It's just simply exchange the position of these two entries from A and change the sign of these two entries and multiply by the inverse of the determinant of A. And if it's not modular system, then usually this number is a fraction, right? So like 1 over determinant of A. But now this is modular system, so we cannot accept any non-integer value. So there must be something else for this, right? Okay, the determinant of original matrix A can be calculated by this cross product with subtraction, and we have negative 549, and if you divide this one by 26, the remainder could be negative 3, but usually we only using positive numbers because of the position of letters or something like that. So instead of negative 3, we can put 23. We already have done this one before, right? Just simply adding 26, as many as we need, until we get the first positive number for that. Anyway, if that is determinant of A, then the inverse of that number with modulo system, like a 26, we are looking for the inverse of 23 modulo 26, which is 15, and we cover this one in chapter 2, and we have the table for that, so please look at that one. But in reality, we don't want to memorize the whole results, right? So please kind of practice a lot how to get the inverse of certain number with modulo system. Okay, then negative 24 and negative 25 is congruent to 2 and 1 modulo 26. So inverse of the determinant of A is 15, and 17, 2, 1, 3 is going to be the same as this one for modulo 26. So you could use this one for calculation, of course, but you need to get this remainder, whatever these numbers you got. And sometimes it's much better to change like this kind of numbers, right? Simple enough. Anyway, these are the residues for each of these entries for modulo 26 for the inverse of matrix A. Then all we need is just multiplying this matrix to the ciphertext for each couple of them. So the first two number for the ciphertext is CI, so is a 2 and 8 for CI, so 2, 8 times this one in that order, then it will giving us 12 and 8, which is M and I. So if you do the same thing for the remaining parts of this ciphertext, this is going to be what you get, and we have extra X at the end, and we can assume that it's not necessary. Okay. First of all, there are many IS or SS and Ps in there, and you can see all these same letters converted into different letters, and that's the power of this Hill cipher. And if you want to make more secure cipher system, still using Hill cipher but more secure, then you can increase the size of your key. So it could be 4, 6, 5, whatever. Then the matrix A should be 4 by 4 or 5 by 5, depends on what the size of the block. So this is a summary for Hill cipher. Each block of n letters of plain text is placed by a block of n letters, depends on what dimension of your matrix is. And if A is n by n matrix, right, then to get the cipher text actually number, all we need is just calculating A and P. Of course, at this moment, the dimension of A should be relative prime with 26, right? And the determinant of A should be, technically the determinant of A should be the relative prime with 26. Because if it's not, then you are not going to have the inverse matrix of it, right? Please check and review the matrix. Just to look at any linear algebra book, you can find that one. So because of this condition, we can guarantee there is inverse matrix like that, so it's going to be very easy to get the plain text from the ciphertext.